Okay, let's continue this. Let me close this one. All right. Now we got state, razor, writer, and writer and the reader basically just for you to understand state because it's bidirectional state. So we're gonna use state from this moment on, and we have another set of examples, which will introduce a concept of monad transformers. Monad transformers are monads themselves, right? And to solve a particular problem with using multiple monads in your code. Okay, so I start with a very simple example. We used before that we have a get Pokemon function going to the network. When you run it, it goes to the network, grab a particular information about a particular Pokemon. Right? Inside, it has a utility function which takes a URL with a key embedded, so you know which Pokemon to get. Right? And this fetch JSON is returning a Fantasyland. Well, it's a functional promise. So when you run it, it actually goes out. If you don't run it, if you call a fork method on it, it goes out to the network and fetch stuff. Otherwise, it just sits here, does nothing. Okay, we talk about this in week 2. Yeah. Now I have this value, a Pokemon, which is calling this function get Pokemon 1. The type for it is a promise of either arrow or a Pokemon. So it's two layer, promise and either. Right? And I have a moves value, which after the Pokemon being retrieved, I'll get the moves key out of that Pokemon. And safe prop returns a maybe. It's a functor itself, so you need to map it to take the first 5. So basically, up to here, it says if you get a Pokemon and when you run it, it will retrieve a Pokemon. Okay? And if it successfully gives you a Pokemon, that means the either side will be a Pokemon instead of the arrow. Then I grab the moves and take the first 5. The moves type signature will be very similar to this. Next one, promise either. Now it becomes maybe list of move. Yeah. Because the moves is a promise, I need to fork it for it to go out to the network and retrieve stuff. That's the difference between functional promise and ES6 promise. Yeah. I fork it, pass a callback, will take the value inside. So the value inside is either arrow or maybe moves. So I just deconstruct those things and log the result. I run it, you get a sense of how it's constructed. Takes a while. Goes to network. Okay, so stuff on here. It gets the first 5 moves. That's the log message I have here. If everything works, it gives me this array of moves. This part could be scary. If you don't understand, it doesn't really matter. What actually matters is this thing. These 2 maps. What do they do? the first map, because it receives Pokemon, right? The first map is mapped into promise. The second map is mapped into either arrow, that's a functor, yeah, to this value. So you have two layers of functors, right? So you have two maps. Okay. Let me comment this out. Next one. We just learned the state. Let's use it. We know that fetch JSON takes a URL, but that URL should be in environment. Right? I should rate that from environment if you have a good architecture. So what I do is I have a new function here, takes the ID, which produce the promise either arrow Pokemon as before, but that's wrapped inside a state. This is a functor. The app state is like this. Is an object with URL as string. So state.get, again, that's a functor, right? I can map over it, which give me all the state, which contains the URL. And then I call the fetch JSON before. Now the URL is an environment variable. I can feed in later. Okay. And then now I can use that get Pokemon 1 to do things. Be aware that now I have 3 maps. Why? Because that's one layer of functor, that's second layer of functor, that third layer of functor. Right? So in order to get Pokemon, to map over it, to get the moves out of it, you need 3 maps. The code here doesn't change, right? It's exactly these 2 lines of code here to get moves. But the maps increases because now you have another layer of functor. Then running it. By running it, I need to pass environment now. Now that particular piece of URL becomes environment variable when you run the state. So let's have a look. Same result. Okay. 5. But the difference is 3 maps. Because you have capability to separate your environment with your code now, but on the other side, you need to write 3 maps. You need to keep tracking how many maps you need. Okay. Now, let me introduce a way to solve it. I have this type called constructor called either T. The T stands for transformer. What does it do? Well, just read the example first, and I'll go to the code. This either T is an outer layer of type promise. So it transforms promise to have the capability of right and left. Promise doesn't have that functionality, right? But either T promise has that functionality, has the left and right functionality. And by doing this, it generates a new type. We call it MTS, Mona Transformer Stack. It stands for. And because the get Pokemon before returns what? A promise with either inside, right? I change its type using this constructor. So it can, on the first layer, without mapping inside, on the first layer, it has capability of operating left and right. Now look at this. m.map. I can write it in a different way, but let's do this. Only one map. These 2 lines of code are exactly the same. Right? These 2 lines of code are exactly the same as before. right? Okay, but only one level of map. Here is 3 level. Here's 1 level. Right? Let's examine what happened with this code. So when we call the get Pokemon, we have a type promise either error and Pokemon. That's the type. Yeah. When I call map once, I have this type. Call map twice, I have this. Yeah. Okay. The either t promise, this part, it generates a new type. What does it do? It delegates this map. Imagine this. What if you on this promise? What if on this promise, the map is implemented like this? Well, promise.prototype.map equals to map takes a function, right? Okay. So, and then what it does is to say, I write in English here. Check if I contains a functor. If I contains a functor, then call the map on it with f. So it delegates this function into the either. So you can map them, because this is a functor as well, right? If promise can check to say, if I contains a functor, then I can just delegate this f into that. If not, what I do, I just do the usual stuff. Yeah, just map, keep this f whatever here. Either t promise, the type generated by that is exactly this part. It requires this type passed to either t to be a functor, at least. Actually, it requires it to be a monad, but for map, to delegate the map, it needs that to be functor. That's how either t is implemented. Make sense? So the type generated by this is a functor as well. When you call the map on it, for example, this is a type e, and e dot of 1 dot map some f, is that this f is delegated inside here. This f will be getting this value, the type of this value, the value of this type directly, not that. So let's have a look how it's done. Hopefully it's very straightforward, the either t implementation. Seems like it's not. Okay. We can have a look at the chain method instead of map, because the map function is actually derived by chain. So here, the either t.js, what does it do? Look at those things. The run is what it encapsulates. So it's the value inside. It's another functor, or it's another monad. And cost chain, it delegates the chain onto that. So this way, the f here will not receive, a monad or functor, you receive the value in the most deep layer of your functors or monads. It keeps delegating until it hits a thing that's not a functor or not a monad. Just visually think about it as a layer of things. When you call map, it goes to the bottom, give you the value, instead of give you the next layer. That's what either T does. This one is just a simple, I think it doesn't have a state here. It just encapsulates two layers. One is promise, one is either. Okay. Now, there is different ways to generate a monad transformer stack value. Here we use a constructor like this. Because getPokemon returns a promise either arrow or Pokemon. If we have this, I cannot use that constructor, just let you know. We need a either here to use this constructor in order to get rid of the map to become a 1. That's one way. The second way is using this function called lift. This is a more simple example. I have the same monad transformer stack, either T onto promise. And then I have promise of 1. Now here is promise of integer, right? The type. But before it was promise either arrow and Pokemon. This is the value encapsulated. This is the value encapsulated in the monad, right? These two, the difference is that we have an either here, another layer. But here we don't. We don't have another layer, right? The promise of 1, correct? There's no either here. But this type is of that type. My stack is either T promise, so I can use MTS lift that promise into that stack. This M will be of type either something. The promise of is only promise integer. But after lifting, I will get either inside. This is just very crucial, the orders. So I have a promise of integer. Right? That's the type of value inside this functor. And if I do lift that type, it becomes promise. This does not change. It will inject an either something into it. It could be arrow, it could be other things, I don't care. It's just inject this functor in the, not in the, like here is in the middle, but it's actually goes all the way down to get that integer and put that integer into either. And then encapsulate the whole thing in the promise. That's what lift do. But by looking at this, the either T, the type is generated by this. Right? It's reversed. You say either T promise, but the value is of this way. Yeah, that's very important. That means if you have multiple transformers, the order you define them will end up in value-wise reversed. Yeah, so like another something state t, some t, either t promise, and then here you will have promise first, state, blah blah. They all reversed the final value. That's just one thing to note. Okay, so let me just check. If I run this, give me 1. Why? Here I have a promise either a integer, right? The outer layer is either t. Either t has a dot run. That's either t give us. The dot run gives you the type inside. The type inside is promise. The promise, when you fork it, it runs. But when it runs, everything reverse. You get this value is not that 1. Is either a 1. Right? You understand this? So the promise here of 1, if you run it directly, let's try this. This will be 1. Right? This line of code. Yeah? I have a promise here, I fork it, and I log the value inside. On the callback, it will be 1. Because I lift that exactly the same promise with this transformer, when I fork it, it gives me a either. It does not give me 1 directly. The right side is 1. Now you embedded the either by lifting into a promise. Okay, here's that example. That's second way of using transformer. I think this is the same, is it? T. This is the third way. Because any monad, any transformer will give you a monad. Every monad is applicative. That means you have this of there. Now we on the top level, MTS, the top level, right? To say of 1. What's the type? The type will be exactly like this. Yeah? Let me just, yeah. So you have a plain value you can put into a transformer, and it automatically gives it either and promise, give you the entire thing with a value embedded in the end. And this forking is just exactly the same as before. Now that's the third way to use it, to generating a value for monad transformer stack. Now we're adding state t to the mix. We have either t now to a promise. Before we have this, like we use state to get the URL from the environment. We're using either to encapsulate the successful or failure of the promise. We have a promise, a functional promise, you need to fork it to run. Now we're adding state t to this stack. What we do is we import this state t. We say first we need to give this promise a capability of asking environment and logging stuff. So the state t promise, that's my middle layer. And then I use that, put in either t, it give me another 3-layer monads. Yeah. I have a 3 monad concat together. And then now I'm getting Pokemon. What I do? First, I ask for the environment. Same. This one, the state t, will give you any method that you have or any property you have on the state. Use it as exactly the same way. So this one you can get. It gets the environment. And then now you have state promise, which lifting that, it will become, let me have a look. So, because this function, fetch JSON, what's the type? Promise either arrow Pokemon, right? That's fetch JSON. But I'm using state promise.get. That means if I do map here, what do I get? I have a URL inside, but the return value is, if I don't lift it, return value is this, right? Promise either arrow Pokemon. Yeah? If I use map, it is not right because promise should be in the stack. The stack gives you the end value, which is that Pokemon value, right? Is not the promise. So I have to lift it into the same level, same type level as state promise. And from a plain promise become a state promise. Because it's a classly error again now, I use this chain. That's what happens here. Don't worry, you don't understand this by now. Maybe another 40 hours to actually to get intuition out of this. But this, remember, we have map for this scenario before. Now I have a simple chain and a lift. By getting moves, exactly the same 2 lines of code, right? The save prop and take 5, but a single level of map. Before it was 3. So this layer, remember we create a MTS which is either T, state T, promise, right? 3 layers of monads. Here it's only 2 level because state T, promise, 2 level, right? Here I'm getting another layer on using this constructor MTS of this get Pokemon 3. And then the map will map to the Pokemon value in the end using the move, getting moves and take 5. And by running it, remember everything is reverse. So the first thing you get is the either T, that dot wrong. The second thing you get is the state is wrong. Now you pass environment like this. Remember before, we have the state. Where's the state? Let's search for it. Before, we're using the state here, right? It's the first layer. Because we have the either here, we run it first. The either layer has been reduced. Give me the state layer. State layer I need to run with environment. And then I have a fork on the promise layer. Yeah, don't need that. Then the value I get is what? Is a value of a state, which is the tuple _1 _2, right? And then the _1 contains a either. The _1 is a either. Arrow and Pokemon. That's the type of that. So what I did is e._1.fork.getter to understand is it left value or right value. of course, the right value contains a maybe because the safe prop. Yeah, so that's a speedy course of Mona transformer stack, and yeah, I think that's about it. Okay, so that's this week.